Hello, this is week 9 and chapter 8, and this time we would like to talk about electrical wire sizing, installation, control panels, all those electrical components that we need to put our equipment together and give it power to energize. So we would like to talk about American wire gauge. Those are the people who are concerned about giving us the standards. And there's something called American wire gauge, which is concerned about the sizing of the wire. So we talk about size of the wire, uh, insulation, and enclosures. Enclosures. It's not writing very well, but it's okay. We'll talk about that a little bit further. And the advantages of copper or aluminum as conductors. By the conductors, they mean wires. And the factor that is considered when sizing a conductor. So by sizing, we mean the gauge, the length, and etc. And National Electric Code, those are the people who actually make up the American wire gauge and set up those standards. We also would like to calculate the voltage drop. What is voltage drop and why do we have to care about that? We will talk about that in a second. Explain the type of enclosures. By enclosure we mean conduits, junction boxes, control panels, covers, all these enclosures for wires, because we don't want to see wires exposed. Wires should not be exposed, and because then it is exposed to a lot, it is subject to a lot of the weather elements, this possibility of being disconnected, rodents, or anything else. We'll also talk about the types of electrical panels. By panels, those are the things that you see in the basement, where you bring power from the outside to the inside. Okay, so installation is a very broad subject. It's very important for service technicians and for people who actually do installation, and we have to make sure that it's done properly. A lot of things has changed in the last 20 years, so probably you've seen stuff that's not up to code from the past, but it has been updated. Some of them are not, and if they're not updated, you might request for them to be updated before you can put a new installation. Some stuff that has been installed before can be grandfathered, and so you should check the code, the town code, for this requirement. And that's why when people like buy old houses, they don't know what is included when it comes to the wiring installation. Changing the wires for one house could cost between like $5,000 to $15,000 to go around and change all the wires and rip off all the walls. So think about that, and that's why also you have to know what are the codes, and that's your responsibility. Go check your wiring for your equipment. Electrical panels, those are the stuff that brings the power from the outside to the inside, and there are different kinds. We'll talk about those. So we know that power comes from the power company, goes through a transformer. The transformer will send power through electrical wires all the way to your house here, and it comes in here and goes boom into your house through an electrical panel. So this is how we bring power from the outside to the inside, and sometimes you have underground wires. So in National Electric Code, they dictate the wire size and type and what goes where. There are two big charts in the book that you can refer to when you need to. They are specific for the applications and amperage. In terms of conductors, I don't want to talk too much about it, but in the past we had aluminum. It was cheaper because there was a time when copper was expensive and not available, so they used aluminum. It corrodes easily. It has a tendency of becoming loose. Also, it fatigues easily, which means it breaks over time. It becomes very stranded. So it's better to use copper. Copper is a standard now, and it has good mechanical strength. And it comes in two types: solid and stranded. So you always want to, they can be the same gauge, you just have to make sure which one is which, And again, we should go with the code. They also tell you you're not supposed to connect stranded to copper. So keep that in mind, even though they're the same gauge. So American wire gauge, they identify the standards. Uh, what you need to know is the bigger the wire, the smaller the number. So it's going to be 0, and this is going to be 0, 0, 0. It's going to be 14, and this is going to be 16, and this is 18. So the bigger the wire, the smaller the number. These are for power cable, like a big power cable, and for us this is gauge 14. That's all you need to. Another sizing system. I'm not going to go too much into it, but you see in the chart, it's called the mil system. It goes with millimeters. Let's look at the chart. So if you look here, this chart, there's two of them actually in the book. They tell you the maximum minimum operating temperature, which is very important because then you will end up charring the insulation and causing fire. And this is the insulation, fluorinated ethylene for this one. This is the AWG, American size gauge. This is the size of that gauge in millimeter, and this is the size in mils, and this is bare wire. So as we go along, and you see this list in the book, you can go through it. It tells you all those specification. For example, this one is for dry and damp location. This is for dry and wet. So some of them are not supposed to be in wet location and so on. Some of them resist UV and some of them don't. There's some here with flame retardant. So there's a lot of that goes into those wiring and how you select them. Probably if you are going to be to go for your test for being licensed electrician, you have to know all this information. Okay, so factors to consider when wiring. First, I would like to talk about, we talked about the size. We should know what size do we need to use. We said 14 gauge mostly. Voltage drop. So voltage drop is the distance of the conductor that must be fed. So the first thing is the voltage drop. So the longer wire will drop more voltage because R will increase. So if you have 120 here, and for each foot there's a drop of resistance. If you go into the table before, you'll see that they will give you the resistance drop, the resistance for that wire per each foot, so you can multiply and know what is this resistance. And as we calculate the resistance, we can calculate the voltage drop based on the amperage required for that equipment. So again, some chart also give you the voltage drop for each foot of that cable. So you have to pay attention to that, but most equipment usually are rated to work between 75 to 100 foot of length. So if you go further than that, you might have to do something about the voltage drop. What are you going to do? You can change the wire gauge, right? You can go a little bit bigger because we said, like, if we have a small gauge and a big gauge of the same length, this one will have less resistance. So that's another option. Or you can consult an electrician and see what is the possibility, what is possible to do to increase the voltage. So we have to care about the voltage drop. We have to care about the insulation type, because we have to know, is this place going to be very hot? Is it going to be exposed? Is it under sunlight? And based on that, we can also know what is the enclosure. Is it going to be rainy? Is it going to be exposed to some chemicals? So based on that, we can also have the proper enclosure. Again, you don't want any exposed wiring. I know you might see it somewhere, but that's not the code. They should always be enclosed. It's a big safety issue. Again, over time, the insulation might deteriorate, might fall apart. If you don't have enclosure, insects or vermin can get into it and chew it. And there's a lot of cases where rodents chew on wires. I don't know why, they're warm or something, or they like to chew on it, but a lot of wire being chewed by vermin, and that will, well, it's good for us because we have to go and fix it, but again, it could be also painful. Voltage drop, again, we talked about that already. Even small can be detrimental. depending on the length, especially when you go with control where you have to calculate the millivolts. So this can, if it's a large drop, you're not going to be able to turn that motor or that pump. If it's small, you might have issues with control depending on the sensitivity of that control. So that's basically one of the main reasons we need to do voltage drop. What you also would like to remember is 3% is the maximum drop as a general rule for branch, meaning from the main. I'll explain now. For 10% is coming to the equipment. So if I want to talk about the branch, so let's say this is my control panel. I have a wire coming all the way from to the burner here, and this is a branch that's operating, let's say, inducer fan motor. For this drop from here to here should not be more than 3%, and the drop on a main line should not, from here to here, should not be more than 10%. And again, inferior cables, inferior wires have a lot of resistance, so you should pay attention to that. And also look at what is the resistance and what is the voltage drop per foot. Wire sizing chart. Those charts are available in the book, the NEC charts. We are in chapter 8. I will give you the chart number. I'm not sure which version of the book are you using, but they should be here. So what I have here is my book is the 9th edition, and this is page 193, and this is figure 8.3. Hopefully it's the same for you, but you can tell from that book you have the American wire size gauge for copper and aluminum, and it gives you the temperature rating, but it does not give you the, yeah, in that chart you should be able to find the voltage drop. I'll post something about the table for voltage drop for wires because I can't seem to find it over here. Okay, I'll post a note about that, but it should be in the so I will stop the video now and continue video number 2. Disconnect switches. Okay, every equipment needs to have a disconnect switch, especially for heavy load like air conditioner or a boiler, and usually we connect through the hotline. So if we have 3 disconnects here, that means we have 3 hotlines. The disconnect switches should be on the hotline, not on the neutral. Some of them have fuses, some of them don't, depending on the load and the code. Fuses provide overload protection, similar to the breaker, which actually will trip. This one will just burn. Some of them are general duty and some are heavy duty, and we also have explosion proof and weatherproof. So check with the codes requirement for what type of disconnect switch you need for your enclosures. Again, the code requires to have enclosures for all the wiring. We don't want to have any exposed wiring, especially for heavy duty equipment, and some of them require that there's no moisture comes inside. If moisture come inside, probably it will ruin your connections, so you don't want to have that, dust or explosive fumes. If we work in a power plant and we have a gas leak, we might want to have leak proof containers that cannot have any water or gas going inside, because if you notice, there's a lot of control included inside the enclosures. Also, there's rain tights. It's going to be outside. Again, explosion proof for location where there's gas leaks and there's a possibility of fire or explosion. for example, power plant. So in here, what they look like. This is a 15 amp breaker, 20 amp breaker, and they also can be, if you notice, this one is double. Why? Because it clips in two hot lines. Meanwhile, this is only one leg that's hot, and they clip inside. This is how they are placed inside the panel. Hot line and a neutral. These are the neutrals here, and it's being installed, and probably this is our ground. Fusible or non-fusible, again, I showed you a picture of the fusible and non-fusible. It's basically a way to increase the safety for these control panels. This is fusible center, and again, if you see, these are fuses between all the hot lines to again, we can use fuse or a breaker. It's not the same. A breaker you can reset, a fuse you cannot reset. Some equipment that are inductive, meaning they have a lot of induction, like motors or magnetism involved, we might not want to use a fuse because the fuse will burn, and there's a possibility of a surge with those equipment. So check with the manufacturer and the equipment requirement whether you need a fuse or a circuit breaker. Okay. Breaker panels, again, if you look here, this is where you clip your circuit breaker, and you see this is the hot line, and this is our neutral. So if you have a double breaker, probably to clip in two hot lines, they call those actually lugs because they can clip to them. And breakers, they detect overload based on the rating unit. If it's 15 amp, if we draw 17 amps or 16 amp, it will trip, so you can go and reset it manually. They can be 1 or 3 poles depending on the setup of these breakers and how many legs are there. So one pole, that could be for 110, 2 poles 220, 3 poles could be more than 220, or could be 3 phase. They are constructed in different ways. Again, note this. It's note this. It's they are not all uniform. Every manufacturer and every control panel has its own connections, and they have their own breaker that are designed to work with that breaker. So make sure they are uniform, and they all have to be UL approved, which is Underwriter Laboratories approval, which goes under the NEC code. Instruction. Main lugs, that's where you connect to. It's called a lug. Those are the connections, and they are rated again by amps. Single 3-phase from 250 or 600 volts. For us, for residential, basically it's going to be 120 or 240 volts. Different shapes, if you can notice, these three look similar, these are different. So different construction with those. Some of them come with main circuit breakers for the entire panel, and some of them don't. That depends on the requirement and the specification. Circuit breaker let's say, cause little or no trouble, meaning that you do not have to replace them. They hardly ever break, and they have been tested for reliability. So whenever they get tripped, you just go and reset them. There's always extra spaces in the panel. You hardly ever go to a panel when you see all the lugs or all the breakers are used. So there's always spare in case you want to add some equipment later on. Before installing anything, this is important. Before changing the breaker or installing a new breaker, you have to cut off the main power, and that's why sometimes we have a main connection to the this is what's called a distribution center, which is a combination of all those little disconnect switches put together in a control room, because probably this is operating a big manufacturers, or also a big power plant. So you want everyone to be handy so you can go and shut off equipment if you have to, or if there's an alarm in one area. So for us, again, we are talking about our power source and how we get power from the control panel. Again, you're not allowed to to connect anything to the control panel unless you are unless you are a certified electrician. We use always AC, alternating current, and the power distribution that has been used for that district is the same for all houses. And from what I've seen so far, mostly every house gets 240 volts. There it is, 240 volts and two hot legs. Many path for electrical current, wires. So we need a method. So as we try to have a complete circuit for our equipment or our appliance, we also need to have a disconnect switch that's appropriate to that service to prevent us from having uh, the system draw more current than it's supposed to, and eventually with more current we'll have more heat and it could burn some control or some wires as we run it. Location for the disconnect switch. So as general rule, you want the disconnect switch to be within reach of the equipment. In case something goes wrong, you can go reach out and unplug it. And it's good to have two ways to disconnect the power from the equipment: a regular switch and a big major disconnect switch that shut off the power from the equipment, and also all the switches around it and the control as well. So this picture will show you how do we connect equipment from a load center. So this is my control panel or power supply center that goes all to the furnace here, and power line goes all the way to the outside unit. And again, if you notice, the disconnect switch is within reach. So if you're outside doing some repair and something sparked or something didn't seem right, you can go and disconnect the switch right away to the entire system going in here. So probably there is a switch in here and there's another switch in here, but that's local, and you want something that will cut off the power entirely from the equipment. Another disconnect switch and a branch circuit over here. And if you notice, again, when we connect the power or disconnect the power, we want to disconnect both hot and neutral lines. So that's the main purpose of the disconnect switch, not only the power but also the neutral. And why is that? It's because in case you have a short in the equipment and there's still some current going through the neutral line, you want to cut that out as well, just to make sure that there's no power coming to the equipment and there's no complete circuit to the equipment, and you can safely work on the equipment by itself. This is also what's called a nameplate. Every equipment should have a label that should give you the manufacturer name, voltage, frequency, phases, maximum, minimum ratings, and what you need, what kind of power required to supply that equipment to have it run properly. So this kind of sums up what we need to know about installation. We learned about American wire gauge, and for us we said the code has changed from last time, from 2016, to include gauge of wire of 14 gauge. Circuit breakers, those what is installed in the control panel. This is the breaker panel. Disconnect switch, you're required to have a disconnect switch in every equipment. Distribution center is when you have power coming to two appliances. Fusible disconnect switch, some equipment require you to have a fusible disconnect switch, but again check whether a breaker is enough or we need the fusible disconnect switch. It is very similar to the breaker. So breaker and fusible, breaker panel and fusible load. National Electric Code is our guide for checking what we need to have as far as wire size and disconnect switch, and also. So again, if you can please remember that. Remember that the maximum recommended size for a branch as a drop from the main voltage source is 3%, and so when we look at the nameplate, we cannot drop more than 10%. So any equipment, whether it be an AC, a furnace, or so on, you cannot have a more drop than 10%. And if you have, for example, very long run of wire and you drop more than 10%, you might want to increase the wire gauge. Like from 14, you might go up to 12 if you have to. Okay, so I will post some questions to check your understanding. Let me know how it goes. Thank you.